Hello ladies and gentlemen, my name is Tom and welcome on today's webinar about smart intersections with Flow. My name is Tom and I'm here with a colleague of mine, Pavel.
Hi, nice to meet you.
And today we'll be talking about how to use Flow as an adaptive sensor for traffic intersections. Today's agenda can be divided into three parts. First, we'll have a look in general how to use Flow in adaptive intersections. Second one is about introducing TrafficXRoads, our new solution made for traffic controlling. And in the last part, we'll have a look on the real-life demo of Flow and how to set different things for the adaptive intersection. At the beginning, let me start with a simple question. Why we don't have smart intersections in our cities? A straightforward question, but the answer varies a lot. The reason might be very different. It can be not having a smart city vision. It can be lacking of experienced staff managing all the traffic systems, or political reasons, budget reasons, or simply too complex systems to be managed. And the last two parts are my favorite. That's the budget and complexity of the system. Let's have a look on a standard intersection in a city. If you want to have an adaptive traffic controlling on an intersection, you have to deploy multiple sensors around it to make it really adaptive. You might introduce inductive loops on different arms on the intersection, which loops are basically cheap, but the construction work and the maintenance make them more expensive. On the other hand, we could have some above-ground sensors, such as radars or cameras, which do not require that much maintenance, but the device itself is a bit more expensive than the inductive loop itself. Unfortunately, all of them are simply individual sensors focused on their job to detect their use case to provide data about. And that, at the end of the day, means that if we really want to make an adaptive intersection, we have to deploy dozens of sensors on an intersection, which makes it too complex to manage and too expensive at the end of the day as well. And that is exactly the thing which we are addressing with Flow. Flow, as a traffic monitoring system, integrates hundreds of different sensors into one user interface into a single system. It is a simple plug-and-play solution where you just connect the traffic camera, and from the video analytics, the engine starts detecting and categorizing all the vehicles it can see. There is no need of any special configuration. Everything is automated right away. And last but not least, the user interface is super easy to work with and extremely user-friendly, so anyone can really create any type of sensor needed. But you will see on your own in the real-life demo part. Let us have a look where Flow can be installed. There are three different platforms where the Flow application can run. First one is directly on the camera. That's this one. This is an example of AI camera where the Flow is running directly on it. It's all in one device. There is not needing anything else, and this will do the job of video analytics. The second option is TrafficXRoads unit or edge processing computer, such as this one, which has already integrated PoE ports to connect standard IP cameras to it. And this can analyze multiple cameras at once. Both of them are ideal for traffic controlling, for edge processing, as there is no need of streaming the video images anywhere, but everything is happening on site. The third option available is Traffic Enterprise solution, which is a server-based solution, as you can see here. There, the software is running on a server in a centralized data center, and all the streams from all the cameras are then sent to this server everything is on one device. This option is ideal for some sort of a central management system where is needed to get traffic statistic data and not real-time traffic controlling. But now I'll give a word to Pavel to introduce us a little bit more the TrafficXRoads unit.
It is called TrafficXRoads units, or sometimes you might hear us saying X-Roads. Look, it's a simple device. It's really compact and you can install it, for example, in a traffic controller. It's got some PoEs to connect standard cameras and mainly a powerful GPU from NVIDIA to process all on the edge. About TrafficXRoads use case examples. You can do presence detection. That's a simple thing, detecting car in a zone, but you can do much more than that. You can detect bicyclists, pedestrians, disabled people, or even other categories like scooter or more that's coming later. You can gather traffic statistics with this device. So it's a really great tool for data collection. That's a big thing in the cities, don't you think? It's not just for static detection or presence detection. You can do even event detection. And that's a huge topic nowadays. Turning movements, stop vehicle, blocking vehicle, traffic jams, even level of a service. It's simply easily with this unit and with flow. You can even detect a key land occupancy, work when driving, or our newest feature, red light detection. TrafficXRoads units. We've got multiple of them. Let's talk about the version that is most commonly used. It's an edge processing video analytic controller. You can mount it on a DIN rail and you can actually connect up to 6 cameras for adaptive traffic control or even more for other use cases. This unit is capable of detecting 150 frames per second when we talk about detection resolution at 544 or a little bit less, 100 frames per second for higher detection resolution. It's up to you what version you choose. There is a big variety of cameras you can connect, and based on that it's also depend detection distance. The standard is 70 meters. If you use a special camera or use a digital region of interest, you can reach up to 120 meters. That's pretty solid. We've got a standard 7 classes. You can looking forward for more of them. And there is a built-in license plate engine. Of course, we've got a VPN connection for remote support. It can be VPN for your network or even for us as a manufacturer. We are able to get there, support you, and mainly do updates. Those updates are also available over the air. TrafficXRoads unit is really versatile tool when it comes to compatibility with third-party solutions. Let's talk about with what camera we can work. We suggest to use Axis or Hikvision cameras, those two models you see, but we are camera manufacturer independent. That means you want Vivotech, you want Bosch or Hanwha or other cameras, feel free to use them. You can even use an old technology that's already installed on the intersection, that's already installed on the streets, and connect existing camera network to this new modern solution. We've talked about cameras and how we can use the third-party devices. Let's look on accessories. We are again open. We've talked about how independent we are on the side of the cameras. That rule applies for all other accessories. When you check I/O modules, there is multiple versions of them, so you can actually connect TrafficXRoads, the input-output board with relays, for example, and remote things in real life. You can open a gate or send a dry contact to the traffic controller. There is SDLC converter compatibility and you can actually buy it from us. That might be quite interesting if you are from North America. Here in Europe is booming smart micro, and not just in Europe. We know it's a great tool and that's why we implement it. And this is the thing that's on the table right now. We've got a first test and you can gather data from the radar in a similar fashion as you do from a camera. Why not to have a one user interface for all your devices that you are connecting on the intersection? I think that's the way you want to go. And in same fashion, we are adding V2X roadside unit support. When we're talking about cameras, we are saying it is a sensor. It is optical sensor with some limitations and settings that needs to be done or picked properly. Let's show it on those three examples. I would say the middle one, where there is a horizontal field of view 60 degrees, it's most commonly used because often you have some virtual loops that you want to design on the intersection. One will be close to the stop line, second one will be far away, maybe 70 meters far away from the intersection. So horizontal field of view 60 degrees is the best scenario for this application. Just to be sure that you correctly counted the blind spot. For 60 degrees, it's approximately 5 meters. That means you need to be at least 5 meters far away from the stop line. You can check other limitations on the next slide. There is quite a lot of criteria and it might look complex and complicated at the start. But do not be afraid of any of those parameters or settings. We will always help you with all and everything. If you have interesting project or just want to know our technology, we are capable of coming to you, helping you with all the settings, or we can do remotely via Teams. We can connect to your network and do all the settings for you at the very beginning. Let's do a first project like this. And then we train your engineers how they should use and copy paste this technology to other intersection. We believe that the support is a really important thing and we wish to give you the best possible support. So if you want to do POC, if you want to do a project with TrafficXRoads or our other technologies, do not be afraid to ask us for coming to you or giving a proper training to your personnel. We like to do pilot projects and we like to do them in Zlín. It's almost 2 years since we did the first adaptive traffic control there, and we come again to Zlín, and right now we are having a first installation with TrafficXRoads there. We replaced 10 inductive loops with this solution, and it's important to say that there is a full data integration with traffic controller. That means no relays, no input-output boards, no things that you don't need, just direct communication over the internet with the device, with the traffic controller. It's easy, it's fast, and it gives you much more data and much more ways to work than just simple presence in a zone based on triggering the relay or dry contact. You can detect the vehicles quite far away, 88 meters during the day, 70 meters at night. But let's look on other slide when we describe, when you can actually see some pictures from the installation. Look, we've got the multiple cameras there. It's because it's our testing intersection and we doing multiple things there. For the full setup, we needed 3 cameras and there was a 15-minute installation time per camera. Setting up the unit is really easy. You just type in IP address of the device, you connect to it, you type your username and password. And by the way, we have a complex user management system, so you can even have a admin or someone who got just viewer permissions. And once you log in, you the camera streams and you the easy setting. So let's start with the camera number 1. I've got the RTSP stream of the camera. I add the new analytic. I type the name of the camera, so let's call it cam1, and insert RTSP stream that I got from the camera. I will repeat this process for all three cameras and connect this way all the video analytic sensors. See, it was really easy. Once you connect all RTSP streams to the flow, you can do other setups. So let's pick camera number 1, let's look on the detail, and let's set up all you need for adaptive traffic control. First of all, I will do category filter, then I create a zone. I put on those zones UDP syncs to have a direct communication with traffic controller. Of course, we are providing other technologies to connect with traffic controller. You can do REST API. There is a possibility of webhooks, and most commonly used for the early stages of implementation, input-output board, such a relay board. So let's jump to the thing. I do category filter, and I set it up just for vehicles that I'm interested in. So I pick car, light vehicle, heavy vehicle, bus, motorcycle. I'm not interested in pedestrians and bicycles at this very moment. For example, you can do prioritization by picking just a bus and having a virtual loop just for buses and public transport. You are not limited by the number of the virtual loops or zones or gates or other tools that you can use. So you can do as many you want. Now I will do zones. There is a simple feature how to do that. You just click and draw. This is a near zone, near virtual loop for detecting vehicle on a stop line. If you don't like the shape, you can actually edit it. You can add some points to have not a regular shape and work with the zone as you want. I will create one for each lane, and now I will do 2 extra zones for far away detection. This is approximately 70 meters far away from the stop line, and it will be useful for detecting vehicles that are approaching the intersection, and in case you have, for example, total red during the night on the intersection, it can detect the car and send the controller information enough in advance so you can turn the green for this specified vehicle. Once I got all the zones, I drag and drop them to the canvas. If you don't like the names, you can actually rename the zone. You can do it here, ABC, or whatever you like. Or you can actually click on the zone settings and play with the name here. As you can see, there is a timer mode. If you wish to gather data, you leave it as it is. But if you wish to do adaptive traffic control, you are interested in the presence of vehicle in a detection zone. So you simply pick timer mode now. Let's do the same for all other zones that we've created. Once we drag and drop the zones in the canvas, we do some additional settings. I really like to put them next to each other, so it's more easier to work with it. I set up a now timer mode for all of the zones, so we will be getting just data about the cars that are currently in a zone. And I will connect them with category filter. That will allow us to calculate just vehicles of a specified category that are in the zone. I've been mentioning syncs, so let's put some syncs on the top of the zones. Here is a zone sync, and you simply drag and drop it on the top of the zone. Again, you can change the name, you can modify, and then you will have it as an endpoint for your traffic controller. We've set up all the zones, we put on the top of them syncs, and we set it up the right category filter. What's next? Let's check if the thing works. We are in a definition right now, and we will jump to Diagnostic. Here in Diagnostic, you can see quite a lot of things there. What's important right now is to check things. You can see type, ID, name, that is really important, time mode, snapshotting policy, and other informations. How does it work? You can actually find on our website. You can check for the full documentation there. Maybe just let me say this UDP protocol is really fast. It's low on data usage. It's just a few bits that we are sending. You can get just a true false value. It's really simple to work with. And your traffic controller will simply subscribe to this name and getting data for as long the traffic controller decide, or maybe better to say your engineers decide. We've just created things. Now let's look to the dashboard. It's actually other cool feature that you can do in a matter of seconds in Flow. You can visualize all the data in really nice and simple way. You can get average speed for vehicles on the intersection, counts, classification, heat maps, trajectory view, even in complex scenarios based on expression widgets that you can program in JavaScript as per your needs. As other feature in the Flow, you can actually add interfaces. It might be a simple relay board that you set expression for, and it's doing the thing what is needed. That means triggering relay based on the logic you create in a Flow. The relay interface is not the only one. You can actually add also SDLC interface for communicating with, for example, Econite traffic controller. Here you can see how it works. It's again really simple and fast to deploy.
As Pavel already mentioned, Flow is an optical sensor which has its advantages and disadvantages, as any other technology. Here are some limits of the solution. So, for example, we cannot see behind an obstacle, which is quite obvious. We can see only what we can recognize from the image. So, for example, fallen object is very difficult to be recognized from an image. The sensor is affected by weather conditions. Of course, if we are talking about quite dense fog or heavy snowfall, this will have an impact on the detection. And the speed detection is not a direct detection as with the radar, with the Doppler effect, but it is a calculated speed based on georeferencing points or based on section speed or average speed between two gates. On top of that, of course, we can recognize only objects which we know. We cannot recognize something what the algorithm is not trained on. So as of now, we are recognizing 7 classes, and we are working on extending it to 20 classes. So that will be already quite a huge step forward. And every object needs to be at least visible with its 60% appearance. So if we see 60% of the object, then the algorithm is already capable of recognizing it. And each object needs to have 10 pixels per meter in detection scale, so it is recognizable for the algorithm. If we see a far object which does not have this resolution, then it is very difficult for the algorithm to detect or categorize the object. If you need more information, we have an online help section where you can find all the data sheets and manuals and everything needed for you to work with Flow, to show you how to set different things, how to set up different types of sensors and so on. Just go on our website and there you can find our help section. TrafficXRoads unit is not only about integrating with traffic light controllers, but the ultimate feature of TrafficXRoads unit is to combine multiple sensors into one system, into one user interface. Therefore, it will become multi-sensor tracking solution, detecting vehicles all the way across an intersection between multiple sensors, multiple cameras or radars, providing all the data in one. The demo of this feature will be demonstrating on Intertraffic Amsterdam next week, where we are welcoming you to visit our booth. We'll be on 05.401, where we'll be showing you much more of our portfolio, not only the TrafficXRoads unit, but also traffic drone or smart parking solution. We are also participating on Intertraffic User Experience Award, where we were nominated with our flow, and we are super excited to hear the results on the Intertraffic next week. Just visit us and we can discuss all the questions you'll be having. Looking forward to see you there. And thank you for your attention. Thank you for being here with us. We'll see you next week at Intertraffic. Have a great day.